Hello. Let me add on a little bit to the end behavior because I was just looking at your assignment. There might be parts in there that you don't know how to do this, and I don't know if it's fair of me to expect you to figure it out at this point. Talking about the algebra, and I think Miss Palmer covered this if you were LCAP last year, but if not, I will help go over it now. So this says what's the end behavior algebraically, and the trick here is I don't want to give away what you should have figured out. But we want to reduce it down and hopefully look for some patterns. So if we plug in, because idea algebraically is that just means you plug in infinity, positive and negative infinity, and see what happens. But if you plug in positive and negative infinity here, I mean, you can see that when we plug in positive and negative infinity, if we want to look at the limit as x approaches infinity of f of x, in this case, infinity squared, if you do a million times a million, you're going to get a really large number. Adding 3 million, adding 3, that's not going to affect it on the very large scale, even beyond the millions. So when you look at end behavior, really you're just looking at the highest power, because that's what's going to have precedence and power. That's what's going to have precedence. So if we plug infinity, we're only looking at the x squared, and this one is just going to be x, in which anything squared over x, obviously the squared is going to continue to blow up. So this sometimes is referred to as big over little, in which big over little, when you talk about fractions, approaches infinity, when you have the limit as x approaches infinity. And when you talk about fractions, 1/2, if the numerator is larger and continues to get larger faster than the denominator is going to get larger, well, that's going to get, as a number, as a value, that's going to get larger much faster and even faster as time goes on. So in this case, we know that this is infinity. But the trick here is how can you get this because of the big over little? And how do we know, if we wanted to know the slant asymptote, what's the slant asymptote even, like I talked about in the previous video? So we're going to factor the top here. So this is actually going to make f of x equals x plus 3x plus 1. A little trick with factoring binomials when it's to the second power is the first two always have to multiply to the first. So x and x is x squared. The last two have to multiply to the last one, which you think about factors of that. You want factors of 3 or 3 and 1, and how to use a combination of positive and negative to get to that middle, in which, in my head, I know that that's going to make 3x, and that's going to make, oh, there's a mistake. This should actually be plus 4x. It's going too quickly. So you get 3 plus 1 makes that 4. And in my head, x and x is x squared. That makes the 3x, and that's another plus 1x. So 3x plus 1x is the 4x. And then this will go down to 1, or cancel. So we really just end up getting f of x equals x plus 1. Which, notice, if you plugged in infinity, you get infinity here. But this actually tells you your slant asymptote. So yes, it's going to approach infinity, but it's going to follow it at the slant asymptote as of f of x equals x plus 1. So the limit as x approaches infinity of f of x equals positive and negative infinity here. Well, that's not true. The limit as x approaches infinity is positive infinity. The limit as x approaches negative infinity is negative infinity. But the slant asymptote is x plus 1. Right? Now over here, notice that it's not big over little anymore. The highest power is 1, the highest power is 1, in which these are the same. So if we look at the limit as x approaches infinity here of f of x, and we just tried to plug it in, the plus 1 minus 5 won't really matter when we look at the large scale, and these will matter. But really what we can actually do is just look at the 3x over 2x, in which the x's will almost just cancel because it's the same thing on top and bottom, and what you end up getting is 3/2. So the limit as x approaches infinity of this function is going to be 3/2, which, by the way, is a horizontal asymptote. So that's when you get like same over same, not big over little. Right? And then this last one here, if we factor, notice how it's small over big, or little over big, however you want to refer to it. Which, if you think about fractions, you have like 1/2 in the top stays small and the bottom is getting bigger, right, that's getting closer and closer to 0. So little over big approaches 0. So the limit as x approaches infinity of this function is going to be 0. And if you want to see it from a different viewpoint, say we factor that, you would have x minus 2, and on bottom you would have x. 16 is 8 and 2. To get a positive 6, it would be positive 8 minus 2. These will cancel, so you get f of x equals 1 over x plus 8, where x can't be 2. And technically up here, x can't be negative 3. And then if you plug infinity, it's just going to get closer and closer to 0 as that fraction gets smaller and smaller and smaller. So hopefully that helps you with the algebraic portion of end behaviors. As I look at this, it looks sloppy. Hope you followed it start to finish. And there you go.